Hello students, very good evening to all of you. So today I will continue the PYQ of the engineering services main examination. Some of the questions I have covered in my previous lectures and further today I will cover. So since it is a very important vital subject for the engineering services, we will find a short questions of moment distributions and slope deflection method. So that's why I am focusing more on this chapter. So let's continue. This question came in engineering services 2012 and have 20 marks. Analyze the rigid frame shown in the below figure by moment distribution method, taking flexure rigidity EI to be uniform for all members. So it has two vertical members, 5 meter, 4 meter, and there is horizontal load of 50 kilonewton which is acting at this point, and a UDL of 15 kilonewton per meter covering both these span BC and CD, and this end is fixed and this one is hinged. So I have to analyze the frame by moment distribution method. So as usual, sign convention, I will find the fixed end moments. Fixed end moment first. So fixed end moment first. Sign convention is clockwise moment positive and anti-clockwise negative. This is the standard sign convention which we have to follow. And the usual concept of sagging and hogging will only be used while drawing the final BMD. Till then, use this concept clockwise and positive, anti-clockwise, negative. In these two chapters, in ongoing chapter of moment distribution as well as in the coming chapter of slope and deflection methods, the sign convention is as simple as that: clockwise positive, anti-clockwise negative. And unless we came to a drawing the final diagram of the bending moment, use these conventions, and while drawing the final BMD, we will use the concept of sagging and hogging. Till then, simply we have to use these sign conventions. So fixed end moment for this member, it will rotate like this. So this will be anti-clockwise. This is anti-clockwise, means negative, and the value will be 50 into 3 into 1, this 2 square upon L square. This is the formula. So you will get this value. Similarly for BA and BA, this will be, so this will act as a fixed, this will rotate like this. So moment will be clockwise. So this will be clockwise moment, it will be positive, 50 into this distance into this 3 square upon L square. You will get this one. And fixed end moment for BC member, so it will be anti-clockwise and this will be clockwise. So MBC is anti-clockwise, means negative, and formula is WL square upon 12. So 15 into L is 8 meter, on 12 negative, MCB, this is clockwise, so it will be positive and value will be same. Similarly, for this member MCE, no load is acting, so MCE is equal to MEC is equal to 0, and fixed end moment for this member MCD, fixed end moment, treating it as a fixed beam, so it will be 15, this is negative, and this one clockwise, so it will be negative 15 into L square upon 12, and MDC will be positive and the value will be same. So you will get these fixed end moments, the value will be this one. So now these are my fixed end moments. Then I will find the distribution factor. So distribution factor, there is a table: joint member relative stiffness, total relative stiffness, and distribution factor. So for this joint, there are two members, one is BA and BC, and this end is fixed and this end is also fixed. So relative stiffness will be I upon L. So I upon 5, this will be I upon 8. This is I upon 5, I upon 8, and I will multiply this numerator and denominator by 5. So I will get 5 upon I upon 40. This I will multiply by 8. So now the denominator of both are same. Sum of this and this is 13I upon 40. This is total relative stiffness of this joint, and distribution factor is this upon this, you will get 8 upon 13, and this upon this you will get 5 upon 30. So these are the distribution factor for members BA and BC at joint B. For this joint C, I have 3 members. One is CB, then CE and CD. So for CB, for this member relative stiffness will be I upon 8, and for this member, since this end is simply supported hinge, so it will be 3 by 4 times of I upon L. For fixed, it is simply I upon L, and when the other end is hinged, so it will be 3 by 4 I upon L. And for this member also, it will be CD 3 by 4 I upon 6. So it will be so these are members. So this will be 3I upon 16 you will get, and this will be I upon 8. So for making this denominator same, I will multiply this by 2 and this by 2. So I will get this one. Now this is 2 plus 3 plus 7. So 7I upon 16 sum, and distribution factor for this is 2 by 7. 3 by 7 and 2 by 7. You will get the distribution factor. So these are my distribution factor. Relative stiffness, CD, sum of these three is this one. So divided by this and this divided by this, you will get these are the distribution factors. Now I will make a table like this. So this is a table, and so just like my actual frame, this is the table. So these are my fixed end moments. At this point, this for this member it is minus 24 and it is plus 36 fixed end moments. For this member it is minus 24 and plus 36. Minus 24 and plus 36 for MAB, and this is for BA, and these are my distribution factor. For this member it is 8 upon 13, and for this member distribution factor is 5 upon 13. For this member it is 8 upon 30, and fixed end moment at this joint is for CB it is plus 80, and for CD it is minus 45. So this is minus 45 plus 80. So it is minus 24 plus 36 and so distribution factor for this member, this is A, B, A, B, C, D and E. Minus 24 plus 36 like this. So it is 5 upon 13, 8 upon 30, 5 upon 30 is for this, and for this member it is 8 upon 13. Similarly, for this member distribution factor is 2 by 7, 2 by 7 and 3 by 7. So 2 by 7, 2 by 7, and for this member it is 3 by 7. So these are my distribution factors. Now at this joint, for joint B, the sum of the moment must be equal to, first I will start from this. At this D there is a moment of plus 45, but since this end is simply supported, it is, this one is hinged, So I have to apply a correcting moment of minus 45 so as to make it 0. But while applying this, since I have applied a minus 45 kilonewton meter is the correcting moment, so half of this will transfer here and of the same sign. So this will be minus 67.50 and this is 80. This is minus 80. You will draw a parallel line. This is the usual procedure. Now, if you look at this joint, then sum of minus 80 and plus 36. So, for the equilibrium of this joint B, the sum of MBA plus sum of BC, this must be 0. But this is not, this sum is not 0. So, it is minus 80 plus 36. So, it means it's minus 44 kilonewton is unbalanced moments. So, for this I will apply a plus 44 correcting moment, and this plus 44 moment when I apply, then sum will be 0. But how it will be applied and what proportion it will give to these two members, that depends on the distribution factor. So, for this member I will multiply this 44 by 8 upon 13, and for this member I will multiply this 44 by 5 upon 13. So, this way I will get some moments here. So, this will be plus 16.92 and plus 27.08. This will be plus 27.08 and this is minus plus 16.92. Similarly, for this joint, sum of this moment plus sum of this moment plus sum of this moment, this is 0 already. So, this must be equal to 0. So, it is minus 80 and this one is sum of this moment MCB plus CD plus CE. Sum of all the moment at this joint must be equal to 0 for the equilibrium of these joints. So, this is plus 80 and this is minus 67.0. This one is 0. So, it means there is a moment of minus 12.50 kilonewton. This one is unbalanced. For making this sum equal to 0, I will apply a correcting moment of plus 12.50, and this 12.50 will be distributed in this member, and in this member also according to the distribution factor. So, this plus 12.50 into 2.7 2 by 7. For this member it will be 12.50 into 2 by 7, and for this member it will be plus 12.50 into its distribution factor. For this member this distribution factor is 3 upon 7. So, this will be distributed in these two members. So, it will be minus 3.57, minus 3.57 and minus 5.36 you will get. So, it is minus 3.57 minus 3.57 and minus 5.36. This you will get. So now this moment you have applied some moment at this points. So when you applied a correcting moment and when the other end is fixed, this end is fixed. So half of this will transfer at this point. So it will be plus, half of this will be 13.54. So 13.54 plus will transfer here, and similarly you have applied a correcting moment of 16.92. So half of this will come here and half of this moment will come here. So half of this will be plus 8.46 and half of this will be minus 1.79. And half of this will not come here. Why? Because this end is not fixed. So it is simply supported, so no carryover moment will be there. Similarly, in this case also, half of this moment will not come here since this is simply supported hinged one. So now if you see some of this moment, this is again after balancing these moment plus 27 and plus 16, there is a moment of 1.79. So this 1.79 moment is unbalanced here. What you will do for this? For this 1.79 moment is now extra. This is unbalanced. So for making it 0, I will apply a correcting moment of plus 1.79 and that will be distributed according to the distribution factor. For this member it will be 1.79 into 5 upon 13, and for this member this will be plus 1.79 into 8 upon 13, and this you will get. So it will be plus 0.69 and 1.10. So similarly, if you see this member, in this member this moment 8.46, this moment is extra. So this 8.46 is extra. Now this 8.486 is extra. For making the sum of all the joints 0, so now because due to carried out from this side it is 8.46, this one is extra. This 8.46 will be distributed according to the distribution factor into these members. For making it 0, it will be minus 8.46 into 2 by 7 for this, and same for this. So this will, you will get, it will be 2 point something. So it will be minus 2.42 And for this member also, since the distribution factor is same, so minus 2.42 and minus 2.42. So for this minus 2.42 minus 2.42, and for this member it will be 3/7. So this multiplied by 3/7, you will get 3 point something. This will be minus 3.62. You will get, so this will be minus 3.62. So I have applied this moment for balancing this. Now after applying this 1.10, half of this will be carried over to this. This is a fixed end. So half of this will come here. So it will be 0.55, and half of this moment will come here, and this moment half of this will come here. So it will be minus 1.21, and this will be approximately, you can say, 0.35 will come here. So now this 0.121 is extra. This 0.121 is extra. So what will happen? This moment is extra. So for balancing it, I will apply a moment of plus 1.21, and this will be distributed into this member and this member according to their distribution factor. For this I will multiply it by 5/3, and for this member I will multiply it by 8/13. So I will get, this will be plus 4.46, and this will be plus 7.46 and 75. So this is similarly my this moment plus 0.35 is unbalanced at this point. So this plus 0.35 will be distributed according to these members, and this will be plus 0.35 into 2/7, and this also same 2/7, and for this member I will multiply it by 3/7. So this will be 1 you will get here. So it will be, and this will be minus, since this is plus, so it will be minus 1.0. This is 1.0, and for this it will be 1.5. So this oh 0.10 you will get. I think some mistake I have done. It will be 0.35 into 2/7. It will be 0.04. Oh, this is, it will be minus 0.10 minus 0.10, and this will be minus 0.15. This will get, and half of this will come here again. So this will be plus 0.38 approximately, and half of this will come here, and half of this will come here. So half of this will come here, it will be minus 0.05, it will come here, and half of this will come here. Now this minus 0.05 is now unbalanced. So for making it 0, I will plus 0.05, and that will multiplied by 5 upon 13 for this member. For this member, I will multiply it by 8 upon 13, and this I will get so 0.02 and 0.03. So it will be and this will be plus 0.03. Similarly, this 0.23 is extra here. This 0.23 is extra here. For this, I will apply a correcting moment of minus 0.23, and this will be distributed in this member 2 by 7. I will multiply it. Same for this, and for this member I will multiply it by 3 by 7. Oh, I forget, I think some. So when you multiply it, it will be 0.03, I think 0.06 you will get. So this you will get minus 0.07, minus 0.07, and minus 0.09. It will be minus 0.07, minus 0.07, and 0.09. And half of this will come here. You can say half of this is approximately this one. So now my table is almost complete. So this value was very less. So now I can sum up. So sum of this, sum of this, sum of this, sum of this, and sum of this, you can say here it is 0. Sum of this, so sum of this, it will be minus 9.51 and 64.96. So this is minus 9.51 and this is plus 64.96. You will get this calculation part you can do, and this will be minus 64.96, and sum of this one, sum of this will be plus 82.88. This is plus 82.88, and sum of this will get this is minus 73.66. So this is minus and sum of this will be minus 9.22. So this is minus 9.22. This will obviously equal to 0, and this is 0. So now I have find the total moments at the various joints. So these are my moments. Now my table is complete. So I can plot it like this way. So this is minus 9.51 plus 64.96. For this, minus 64.96 plus 82.88. For this, 73 minus 73.66, and this is 0, 0, minus 9.51 plus 64, and this is 9.22. So this is minus, for this member it is minus 9.22. So these are the final moments. Now apply the moments and their directions. So this one is minus. Minus means anti-clockwise. So if you see from this point, if you sitting here and see anti-clockwise means this moment is like this. This is anti-clockwise, and this one is plus 64.96. It means this is clockwise. This is clockwise. Similarly, for this member it is minus. Minus means anti-clockwise. So it will be like this. For this member is positive means clockwise. So this is clockwise. And for this member it is minus. Minus means anti-clockwise. This is 0 here. And this is minus. If you see from this point, so this minus means anti-clockwise. So now I can draw the bending moment. So it will be like this. At this point, we will make the diagram in the direction of the arrow. So this member, the direction of the arrow is towards this side, outside. So it will be (9.51), and in this also this will be 64.96. So this is 64.96 kilonewton meter. For this member also, the direction of the arrow is what? This also is 64.96, and at this point this is 82.88. So suppose this is 82.88, I will make in the direction of the arrow. This is 73.66, and direction of the arrow is outside. So this is 73.66, and at this point it is 0. So it will be like this. And if you see from here, the direction of the arrow is these directions. So this will be 9.22, and at this point it is 0. Now these are, now I will apply the concept of hogging and sagging. I will apply it. If you see from this point, if you see by sitting here, so this is a, this will be a hogging moment, so this will be minus, so this will be minus. Similarly, this is also hogging, this is also like this and like this. So I will superimpose the bending moment, loading the bending moments, and this will be, so at this point you see there is a load of 50 kilonewton meter. So bending moment will be 50 into 2 into 3. This will be sagging. This will be sagging. 50 into 2 into 3 by 5. 2 into 3 by 5. 50 into 2 into 3 by 5. This will the bending moment at this point. So it will be 10. This will be 10. So 60. This will be 60. So this will be, and at this point this is 2 meter and this one is 3 meter. So at this point it will be, this total is 60, and this is sagging. So now this is, this one is hogging and this one is sagging, and this value you can find by the interpolation. This total is 60. By the interpolation you can find this one. This you can find from the interpolations, and this will be 9.51 plus difference of this 64.96 minus 9.51. So this divided by this length 5 into this 3, you will get this one, and this when you subtract from 60 you will get this one, and this will be, you will get this will be 17.22. It is 17.22 kilonewton. Similarly for this member, my, there is a load of this 15 kilonewton per meter. The load is acting and the length is 8. This is 6 here. So this moment will be sagging and value will be WL square by 8. WL square by 8 means 15 into L is 8 here by 8. This is the formula for simply supported beam, WL square by 8. So it will be 120. So 120 so this will be parabolic. This total is 120 from this point to this. This is my minus, and this value maximum you can find from the interpolations. So total is 120, and this is exactly at the midpoint. So this will be average of this and this. 120 minus 1 by 2 of 82.88 plus 64.96. So this way you will get this one, and this will be equal to 46.08. This is 46.08. Similarly, this portion is, there is also a parabolic, so it will be like this, and this length is 6 meter. So bending moment at this point will be 15 into length is 6 square upon 8. So this will be 105 upon 2 means 52.5. So 52.5 is this one. So this minus this, so 52.5 C sagging minus this will be half of this one. So half of 73.66. So half of this will be 36, 37 something. So it will be approximately 15. So this will be 30. Okay. Right. Oh, it is 135. 135 by 2 means 62.5 you will get. So 62.5 minus 15 into 6 is it will be anyway, it will be 67.5. 15 into 6 square by 8. So this will be 36. 135 by 2 means 67.5. So this 67.5 minus half of this. So half of 73.66. So it will be, you will get 30.67. So this is 30.67 kilonewton. And this simply, if you watch from this, so it will be hogging. So this is minus. So this is now my final bending moment, and it will look like this one. So this exactly is same. So this is the bending moment, final bending moment. Again, this question is also very much similar. It came in Engineering Services 2013 and of 20 marks. So the same procedure I will apply here. This MAB fixed moment, first I will calculate. MAB, this is acting at the center, so it will be minus, this will be plus. So minus WL by 8, this is the formula. And MBA will be plus 1.5. For this member, it is 0. MBE is equal to MEB is equal to 0. For this member, it will be MBC, and this will be this anti-clockwise and clockwise. So minus W4 square upon 12. WL square upon 12, this is the formula. So this will, you will get, it will be minus 2.67. So minus 2.67, and MCB, this will also be same, this will be plus 2.67. For this member, MCF and FC, these are 0. For this member, MCD, it will be anti-clockwise minus W into this distance into square of this upon L square. And for DC, MCD, DC, it will be 2 and this will be positive 2 into 2 into 1 square upon L square. So this will you will get the fixed end moments. These are my fixed end moments. So now there is a table. So this is a distribution table. Distribution table. So distribution table you can make. So this is my distribution table, distribution factor. So table is like this: joint, member, relative stiffness, total relative stiffness, and distribution factor. For this member AB, this is joint B. There are three members. One is BA. So relative stiffness of this will be simply I upon L. I is 2I upon this length. So for this member BC, it will be I upon 4, and for this member BF, it will be, since this end is hinged, so it will be 3 by 4 times of I upon L. I is 2I upon 6. So this will be 3 into 2, and this is 2. So it is I by 4. So 2I by 4, I by 4, I by 4, it will be 4 I by 4 you will get. So this will be 2 by 4, 1 by 4, and 1 by 4. You will get this. So and this you can say 1 by 2. So 1 by 2, 1 by 4, and 1 by 4. So these are the distribution factor for this member. And for this member, for C, it will be like this. Joint member relative stiffness, total relative stiffness, and D distribution factor. For this member C, one member is CB, then CD and CF. The relative stiffness of this will be simply I upon 4, and for this end is hinged, so it will be 3 by 4 times of I upon L, I upon 3. This is I by 4, and for this member it will be, since this end is fixed, so it will be I by 3. So it is I by 3. Now what I will do, I will multiply this by 4 and this by 3 and this also by 3. Now the denominator is same, 12, 12 and 12. Sum of these three will be, this will be So this is 3, 3, 6 and 4, 10. So it will be 10I upon 12. So distribution factor for this, it will be 3 by 10, 1 by 3. Oh, this also be 3 by 10, and this is 4 by 10. You can say 2 by 5. So now these are the distribution factor: 3 by 10, 3 by 10, and this is 2 by 5. So these are my distribution factor. Now similarly, I will make a table and I will do the analysis in the same way. So is this one. So this is my hinged one. So now I can plot the values here. This is minus 1.5 plus 1.5, and minus 2.67. This is minus 1.33, plus 0.67, and it is 0, 0 here. And distribution factor for this member is 1 by 2, 1 by 4, 1 by 4, 1 by 2, 1 by 4, 1 by 4, and this is 3 by 10, 3 by 10, and 2 by 5. So 3 by 10, 3 by 10, and 2 by 5 for this. Now first I will start from this end. This is simply spotted, so this moment must be equal to 0. I will apply a correcting moment of minus 0.67 so as to make it 0. When you do this, then half of this will come here, half of this, suppose this is approximately minus 0.34, you can say. So now sum of this will be minus 1.67, and this is plus 2.67, minus 2.67, plus 1.50, minus 1.50. Now if you see at this joint, the sum of this moment plus sum of this plus sum of this must be equal to 0. So sum of this is plus 1.50 and minus 2.67. This one is 0. So this is 0 here. So it means it will be minus 1.17. This much moment is unbalanced. So this minus 1.17 will be distributed. For this I will apply a correcting moment of plus 1.17 so as to make it 0, and that will be distributed according to this into 1 by 2. Then for this member it is 1 by 4, and for this member it is 1 by 4, and this I will get 0.59, 0.29 and 0.29. Similarly, for this member, if you see, sum of this plus this must be equal to 0. So sum of this and this is plus 1. This one is extra. For making it, I will apply a correcting moment of minus 1.0, and this will be distributed according to the distribution factor. For this member, it will be this into 10 by 7, 10, same, and for this member, it will be 2 by 5. So it will be 0.4 for this member, and it will be so, and again when you apply this, so half of will come here, this end is fixed, so half of this you can say 0.30. Now again if you see, this end is fixed, so half of this will come here and half of this will come here, so it will be 0.15, and this is oh no, half of this, so it will be half of this one, so half of this one be, you can say, minus 0.02, and half of this will come here. Now this minus 0.02 is now unbalanced, so this minus point, oh, this end is fixed, so it means half of this will come here. Now for this member it will be, for making it 0, I will apply a correcting moment of 0.02 into 1 by 2, so this will be point plus 0.01, so this will be plus 0.01, and for these members you can pick any of this, so this will be I think some mistake I have done, so okay. Oh, I think this is the mistake I have done. Since this sum of this is plus and this is minus, so this is plus 1 is extra. So for making it minus 1.00 into 3 by 10, so it will be 0.3. So this will be minus 0.30, not 0.03, and same will be here, and this will be 0.4. Minus 0.4 you will get here, and this I have distributed. So half of this will come here and half of this will come here. And now this one is extra now, and this will be distributed according to the stiffness. It is 1 by 2, so it will be, I will apply a correcting moment of 0.15 into 1 by 2, so it will be 0.08 something, plus you can say, and 1 by 4 of this, it will be 0.04 and 0.03 you can say. So it is 0.04, total sum must be equal to 15, so 0.03. So that the sum will come 0.15, and half of this will come here, so it will be 0.04. And now this one 0.15 is now extra here. So this 0.15 is extra here. So I will apply a correcting moment of 0.15, and that will be distributed like this. So this will be 0.45 you can say by 10. So 0.05 approximately you can say, so minus 0.05, and this you can say minus 0.049, and this will be 0.06 approximately, so as to make it 0.5. So this will be minus 0.05. This you can take slightly less, so that the sum will be 0.15. So this you can say 0.06. So now these are now distributed. Now half of this will come here, and half of this will come here. This you can take like this, and that will be distributed again for plus 0.03 into 1 by 2. So you can say it is 0.02. So it will be 0.02. For this you can say 0.01, and for this you can take it 0. Similarly, for this member I will apply a minus 0.02 correcting moment, this into 3 by 10. So this will be 6 by 10, This you can say minus 0.1 and this 0 and then minus 0.02 something like this. Now it is almost distributed. Now sum of this sum of this and sum of this, sum of this, sum of this, sum of this is 0, sum of this, so sum of this and sum of this is 0, this also 0. Now I will add the values and this will be minus 1.16 and this is plus 2.19 this is minus 2.51 this is plus 2.48 minus 2.01 this is of 0, this one this is minus 0.47 and this is not equal to 0, this will be half of this and half of this, it will be minus 0.20, minus 0.03 and minus 0.01, so it will be minus 0.24. You will get this one, this is 0 here and sum of this will be plus 0.32. So this way I have calculated my final moments. So these are the final moments. Now, so my final moments are like this. So this one is minus 1.16, plus 2.19, this is minus 2.51, plus 2.48, minus 2.01, 0, minus 0.47, minus 0.24, and this is 0.32, this is minus This one is also, this is plus 0.32 and this is 0. Now this is a minus means anti-clockwise. This plus means clockwise. This is anti-clockwise means again this is plus. This is anti-clockwise minus 0.201 and this is 0. If you see this member by sitting here, then this is plus. Plus means anti-clockwise. For this member, I will stand here and I will see this minus means anti-clockwise. This minus means anti-clockwise. So now I will draw the bending moment according to the sign conventions. So I will see the direction of the arrow. So now for this it will be 1.16. This is in the direction of the arrow. 2.19. This is 2.51. So 2.51 is more. So it will be 2.51, then 2.48, almost equal. This is 2.01 and this is 0. For this, in the direction of the arrow, it will be, and this is 0. It is 0.32. Then this is 0.47 and direction of the arrow is, so it will be like this. And on this, I will superimpose the diagram. Since this load is 3 kilonewton, so bending moment at this will be WL by 4, it acting at the center. This into 4 by 4, this is 3. So this will be 3 minus this is exactly at the midway. So it will be average of this 1.16 plus 2.19. You will get minus. So this value will be 1.325. For this member, there is a UDL and the value of this UDL will be WL square by 8. So this will be 2 into 4 square by 8. So this will be 4. And so this diagram will be like this. This will be parabolic. So this is 4, total is 4. This total is 4. So exactly mirror, this will be 4 minus average of this and this exactly at the center. This will be 1.505. And this one is, and there is a load, point load. Bending moment at this point will be 3 into 1 into 2 upon 3. So this will be 2. So at this point, this will be like this. And the value will be, this total is 3. Total is 3 into 1 into 2 upon 3. So it total is 2. So this 2 minus this one, this I can find from interpolation. So this will be 2 minus, so this is a 2 minus, this will be, this is I think 2.51, no, 2.01 upon 3 into this 2. So this way you can find this one, and this will be 0.66, and this will be hogging, this is sagging. If you see from this point, again by sitting here, this will be hogging. So this will where you get the bending moment diagram. So this is my bending moment diagram. So this is the bending moment diagram. Finally you will get, it will look like this. So it is very easy. Come to the question again. This question came in Engineering Services 2015. And of 20 marks. So it is a box culvert, box frame, and for such kind of frames, I will advise a method. One is find the fixed end moment for this member, FEM. This will be for AD, MAD. So this will deflect like this. So this will be anti-clockwise, and this is clockwise. So this will be minus AD, and value will be 2 into 3 by 8, and MDA will be plus. For this member, MAB, MMBA is equal to 0, and same for this will deflect like this. So this will be clockwise and this is anti-clockwise. So MBC will be the same. This will be positive and this one will be negative. You will get the fixed end moments like this. Now distribution factor will be like this. If I take joint A, so this is my joint A. For this relative stiffness upon, this is I upon L. So this I, EI is constant. So I upon 3, length is 3. For this member, it will be I upon 6. So total I can say this 2I upon 6. If I multiply this, so total of this will be 3I upon 6. So this divided by 3, 1 by 3 will be the distribution factor of this, and for this it will be 2 by 3. And this you can apply the same. This is same. If it is 1 by 3, this will also be 1 by 3. And this will be 2 by 3. Same. 2 by 3 for this. And again, if this is 2 by 3, then this will also be 2 by 3 and 1 by 3. And this is 1 by 3 and 2 by 3. So only for one joint you can find the distribution factors. So for A, you can find like this distribution factor. Similarly for joint C and D. Now this is my table. So bending moment at this point is, this is box culvert A, B, C, D, and it is 0.75 and minus 0.75 at this end. This is plus 7.5 and minus 7.5. and distribution factor is 1 by upon 3, 2 by 3, 1 by 3, 2 by 3, 2 by 3, 1 by 3 and 1 by 3 like this. So, and for other member it is 0, 0, 0. So, distribution factor for this and this. So, this is 1 by 3, 2 by 3. Same. Now, the moment is, this is minus 7.5 plus 7.5. For this member, it is plus minus. And for this it is 0, 0. Now, if you see at this joint, the sum of this plus this must be equal to 0. It is not 0, it is minus 0.75. I will apply a correcting moment of plus 0.7.5 and that will be distributed according to the distribution factor. For this it is 1 by 3 and for this it will be 2 by 3. So, this will be plus 2.50, it is plus 5. And the same here, this is plus points, so it will be minus 0.5.0, this will be plus. Plus, this is minus. So, this one is plus, this is minus, it will be minus 5 or minus 2.50. Similarly, this is plus 5 and plus 2.50. The same here, this will be minus 5.0 and minus 2.50, and half of this will come here, half of this will come here. Similarly, half of this and half of this will come here. Same. And same. If you see at this point, now this is my extra. So, 0.1 minus 1.25, this is extra. I will apply a correcting moment. Oh, this is not minus 1.25. This will be total extra moment. Here will be this and this one. So, this is minus 2.50 and minus 1.25. So, the total is minus 3.75. Minus 3.75 is extra now. This at this. For this, I will apply a correcting moment of plus 3.75 and I will multiply it by 1 by 3. So it will be plus 1.25 and this will be 2 times of this. Similarly, this is plus 3.75. So this will be minus 1.25 and minus 2.50. And for this member, it is minus 3.75. It will be plus 2.5 and plus 1.25. Similarly, it is for this member, if you see, then this is plus 2.5 and plus 1.5. So plus 3.75 is extra. For this, I will apply a correcting moment. So it will be minus 2.50 and minus 1.25. So this same will continue. So same now it is similar. So now at this point I will wind up. I will wind up. So now if you see here this and this, so it will be plus 2.5 minus 2.5 plus 2.5 minus 2.5 plus 2.5 minus 2.5 plus minus 2.5 plus 2.5. So we will get these values. It means this is my box. So this is plus 2.5 minus 2.5 plus 2.5 minus 2.5 plus 2.5 minus 2.5 and this is minus 2.5 plus 2.5. So these are my moments. So if you see, this plus means clockwise. So my moment is like this. This minus means anti-clockwise. This plus means clockwise. This minus means anti-clockwise. This plus means clockwise. This minus means, if you see from here, so this will be like this. So you have to see by standing here. If I see from here, this minus means and this plus means. So this is my bending moment diagram. So if you draw it, it will be like this. So in the direction of the arrow you can see. So now this is, you will apply the concept of sagging and hooking here. So this one is sagging. So it is 2.5, 2.5. This also If I see, you have to, on the tension side, if you see from here, it is also sagging. This is 0.25 positive. So if you stand here and you see this is a sagging, so this also is positive. And if you see from this point, it will be like this, positive. And at this point, there is a point load of so there is a point load of 20 kilonewton on this face and on this face. So consider this as a simplest supported bending moment. This will be hogging, and the value will be 20 into 3 by 4. WL by 4, this is the formula. This will be 15. 15 kilonewton hogging moment will be there. So 15, this is hogging. So you can make hogging on this side. This is 15, and this also. Now this is a minus. So minus means like this. Now this is my bending moment diagram. I have not superimposed this in order to make it clumsy. So separately I had drawn this. So this is hogging and this sagging is separately. Another point is this, I can reverse my concept. Let's make the sagging moment outside, means opposite to the direction of the arrow, and especially you have to mention it, especially taking inside faces of the box side reference and drawing sagging moment outside, means sagging moment if you plot outside, then you can plot sagging moment outside, so that my diagram looks better. Sagging outside, this sagging outside means it will be like this. So now this will be on the outside 2.5, this also 2.5, this also 2.5, and this also 2.5 kilonewton. So this is sagging. Only thing is that you have plotted on the outside, and at this point there is a hogging moment of 15. This is hogging and this one is sagging. So if I superimpose, so it will be like this. This will be positive, this is negative. This also, oh, this is negative. This is positive. Since it is sagging, this will be negative. It is hogging. This is positive. So this will be 15 minus 2.5. So it will be 12.5 kilonewton meter. So this is my bending moment diagram. So this way you can draw it. Now this same question I can solve it in a slightly easier way. Easier way concept means, if you see this box, you draw a line. This is symmetrical. This first half is symmetrical to the second half, and in addition to this is symmetrical about horizontal axis also. This is symmetrical about the x-axis and y-axis. So in this way, what I will do, I will make a substitute diagram frame. Substitute frame. This is my substitute frame, and I will consider this one. Half of this means this will be, say it will be B1. This is B1, and I will take this half of this will be 3 meter. Similarly, this is symmetrical to this one. So half of this I will treat this as a fixed. So half of this will be 1.5. Say this joint is D1. Since this is symmetrical about the both way, x-axis and y-axis. So half of this I will take, half of this I will take. It is symmetrical. Now this is my substitute frame. Now one thing is there, everything will be same, but only thing, the relative stiffness of this member now will be half of the relative stiffness of AB. So relative stiffness of this member is how much? This is I upon 6, and relative stiffness of this will be I upon 3. Now for substitute frame, the relative stiffness of this AB1 and AD1 will be half of this. So half of this will be, I will multiply it by 1 by 2. Now this will be I upon 12, and this will be I upon 6. So I can say 2I upon 12. So sum will be 3I upon 12. Now relative stiffness will be, this will be 1 by 3 and 2 by 3. So for this member it is 1 by 3 and it is 2 by 3 here. So in this case of substitute frame, when this is symmetrical, relative stiffness will be half of this one. So half of this will be whatever relative stiffness of this AB member, this is I upon 6, half of this will be there for this, and half of this will. So now it is 1 by 3 and 2 by 3 is the distribution factor for this joint A. AB it is 1 by 3, and for AD it is 2 by 3. And now if you see this member, this joint is whatever distribution factor for this same will be there. So I will consider this portion only. So this is my substitute frame. So fixed end moments already you calculated. So for substitute frame for AB and AD, these are my distribution factor. So now this is the table. So it is 1 by 3 for this, and it is 2 by 3 for this. Moment at this point, this is A, this is B1 now, and this is D1. So moment at this point, so AD, this moment is minus 7.5. AD means for this, it is minus 7.5, and for this AB, it is 0, since no load is acting. So minus 7.5, and it is 0, and this I will not consider. So I will consider only this joint. Now the sum of this moment and this moment must be equal to 0. So for making this 0, I will apply a correcting moment of 7.5, and that will be distributed by 1 upon 3 for this, and by, so this will be plus 2.50, and for this member it will be 2 times of this, it will be plus 5. Now this is a substitute frame, so no carryover for this and no carryover this, and I will not take any moment for this. Now this will be plus 2.50, and this will be minus 2.50. No further analysis is required. Now these are my moments. So my box is like this. This is plus 2.5, and this is minus 2.5. So this, if this is plus 2.5, so obviously this will be minus 2.5, and this, at this joint the sum must be equal to 0, so it will be plus 2.5. If this is plus 2.5, it will be minus 2.5. then it will be plus 2.5, so that this sum will become 0. If this is plus, this will be minus 2.50, and this will be plus, so that this sum at this joint will be 0. Now this is anti-clockwise, this one is anti-clockwise, same anti-clockwise, clockwise. So you have to see by standing here. So this anti-clockwise means, and this clockwise means clockwise means and this is like this, and so the direction of the arrow is inside. So we will make this will be like this, same concept, 2.5, 2.5, and this you can plot the hogging effect, otherwise you can superimpose. Otherwise you can take this, taking inner face as the reference face and drawing sagging moment of fixed end moment outward, and also hogging or symmetry supported. This you will superimpose. This will you get. Now the whole exercise is this looks like very easy, and this way also you can close bending moment on the tensile side, the positive, and this on the this side. So this will also be same. So by using this substitute frame, this becomes very simple. Otherwise the calculation was slightly lengthy in this way. So this way you can do it. Now another question. This is also box culvert. It came in 2025, 20 marks. This is a culvert, 25 kilonewton is weight is acting at this, and there is a UDL of 2.5 kilonewton meter. A, B, C, D, E, I is constant. So you can find FEM. So this for AB and BA it is 0, and same for CD and DC is 0. For this member, if you sit here, so this will bend like this. So MBC will be anti-clockwise, and this will be 24 into 10 upon 8. This is the formula. And for CB, it will be plus 25 into 10 upon 8. And you see, so if you stand here and you see, so this will be clockwise. So MAD will be plus 2.5 into length 10 square upon 12. This is the formula. MDA, this is anti-clockwise. So this will be minus of this. So this way you can find the fixed end moments. So these are my fixed end moments. Now if you see this box, then this is symmetrical about the y-axis. So first half is the same to the right half. So it is not symmetrical to the y-axis, x-axis. This is symmetrical to y-axis. What I will do, I will use the concept of substitute frame. I will not consider this right half, and I will shift this C1 to here and this D1 to here. Now my diagram looks like this. So this is substitute frame. This one is the substitute frame. Now relative stiffness of this will be half of this one. So relative stiffness of this will be I upon 10. So relative stiffness of this will be half of this. Half of this will be I upon 20. And relative stiffness of this will not alter, as I have not cut it. It will be same. It will be I upon 10. So I can say 2I upon 20. Sum of this and this will be 3I upon 20. So distribution factor for this will be 1 upon 3. And for this it will be 2 by 3. So these are my distribution factors, fixed end moment, and I will concept so it is 1 by 3 and 2 by 3. Similarly, this will be 2 by 3 and 1 by 3 for this member. And this is A, D, B1 and D1. So this is my substitute frame, and the value of BC1 will be the same for BC. This value BC is minus 30 point. So whatever moment at this point, that same will be here. So this is minus 31.25, and this is 0 here. At this point it's plus 20.83. This I will not consider. Now at this point, the sum of this moment and this must be equal to 0. For the equilibrium of this moment, sum of this moment and this moment must be equal to 0. So this is minus 31.5. I will apply a correcting moment of plus 31.25, and that will be distributed by multiplying by 1 by 3. I will get this one, then 2 by 3 for this one. So when I multiplied by 1 by 3, I will get, this will be 10.42, and this will be 20.83. Same concept, I will apply a correcting moment of minus 20.83. For this member it will be 1 by 3. You will get, this will be minus 6.94, and 2 times of this it will be minus 13.89. Now if you see, this end is fixed, this end is fixed. So half of this moment will come here, half of this moment will come here. So half of this will be, you will get 10.42, and this will be, half of this will be minus 6.95. So now by this moment is the carried over moment. So this is extra now. I will balance this. I will apply a plus 6.95 multiplied by 2 by 3, and then 6.95 into 1 by 3. So I will get this will be plus 2 by 3 means it will be 4.63 and 2.32. 4.63 and this will be plus 2.32 and same here, this plus 10.42 is extra, this plus 10.42 is extra now. So 10.42 into 2 by 3 for this member and for this is plus, so correction will be minus, it will be 1 upon 3. So I will get this will be minus 6 point yes, this moment is extra, so this will be minus 6.95, this one, and this will be 3.47. Now, and this, now half of this will come here and half of this will come here, apply. So this will be minus 3.48 and half of this will be plus 2.32, you can say. So now this moment is extra. Now this moment is this is one is extra. What I will do? I will apply correcting moment. So this will be plus 3.48 into 2 by 3 and for this member it will be 1 by 3. So this I will get so it will be plus 2.32 and plus 1.16. For this member, I will apply a correcting moment of minus 0.232 into 2 by 3 for this member and 1 by 3 for this member. So it will be minus 1.55 and it will be minus 77. Now, this is the moment which I have applied. So half of this will come here. This is plus 1.16 and half of this will come here. It will be like this. Now this moment becomes extra. So it will be distributed into this member and this member according to the stiffness. So 0.78 into 2 by 3, it will be 0.52 and this will be plus. So plus 0.52 and this will be plus 26. Similarly, for this member, it is I will apply a correcting moment of this into 2 by 3 and 1 by 3. So this will be slightly 0.78 something. So this will be 0.77, and this is minus, and this one be minus 0.39. Now half of this will come here, half of this will come here. This will be plus 0.26 and this will be plus 0.58. Now my this moment is extra, so this will be distributed in the same way. So minus 0.58 correction will be applied into 2 by 3 and into 1 by 3. So this will be 19 something, so it will be 0.38 something. So this will be minus 0.39 and this will be minus 0.19. Similarly, this is 0.26 here, so 0.26 into 2 by 3, it will be minus 1.17 and this will be minus 0.09. The same procedure you will follow. So finally, after doing calculation, you will get this value. This will be minus 9.11. So this you will get minus 9.11 and this will be plus 16.91. And sum of this will be minus 16.91 and sum of this is plus 9.11. So now this is complete. I can use my box is look like this is my box. So this moment is minus 16.91. This is plus 16.91. This is minus 9.11 and this one is plus 9.11. So due to symmetry, if this is minus 16.91, this will be plus 16.91. If this is 16.91, so obviously it will be sum of this is equal to 0, so it will be minus 16.91. So that sum of this moment and this is equal to 0. If this is minus 16 point, so this will be plus 16.91. Oh. Oh, no. This will not be this. Since this is not symmetrical to this, so this moment will be different. So it will be same. This is there is UDL, so it will be minus 9.11. And if this is minus, so it will be plus 9.11. Since this member is, this moment will be equal to this will be equal to this will be equal to this, and this will be. So this is not symmetric. There is a point load, there is a UDL. So this moment will be different. So now if you see my movement is like this. This minus means anti-clockwise. This is anti-clockwise and this is clockwise. By standing here, if you stand here and you see this is anti-clockwise means clockwise means if you sit here then you see clockwise means and this is anti-clockwise. If you stand here and you see minus means anti-clockwise, plus means clockwise. Now make the diagram in the direction of the arrow. So it is look like this one. So in the direction of the arrow, this is you will make this one. So this will be hogging. This will be hogging. So 16.91 and this also 16.91 and this is also 16.91. This is hogging. So it will be in this side and same will be here. It is hogging. In the direction of the arrow, you will make it. At this point, it is 9.11 and I will in the direction of the arrow, I will make it. So it is 9.11. Same in the direction of the arrow, 9.11 and same here in the direction of the arrow and it is outside. So now my this and this is. So these are my hogging moments. At this point, there is a point load. So this point load is how much? This point load is 25 kilonewton. So bending moment because of this will be 25 into L by 4. This is the formula. 25 into L by 4. So it will be 125 by 2 means 62.5. So this will be 62.5 and this will be like this. So total is 62.5. So 62.5 minus 16.91. So you will get this value and this will be 45.59. Similarly, at this time there is a UDL and this UDL will create a sagging moment, sagging, and how much it will be 2.5 WL square by 8 is the formula into 5 square upon 8. So this will be upon 8. So it will be oh, this is 10. So it will be 2.5 into 10 means 100 upon 8. So it will be 250 upon 8 means 30 something you will get. So it will be 30 minus 9.11. So it will be 21 point something. So it will be 22.14. So when you it will be like this. So this is sagging and this is hogging. Your bending moment will be this way. Same I have done here. So your diagram will be like this. This is my bending moment diagram. These are the direction of the arrow. This question came in engineering service in 2014, and this is a very much same. So I will not do much. So same, on the value are different. Now it is I to I. This is my substitute frame. So relative stiffness of this will be 2I upon length 2I upon 5. This is the relative stiffness for this member. So half of this will be, it will be I by 5, and for this member it will not change, it will be I upon 2.5. So I upon 2.5 means 2I upon 5. Total relative stiffness will be 3I upon 5. So it will be 1 by 3 for this and 2 by 3 for this. So these are the distribution factors. Fixed end moment you can find in the same way. These are my fixed end moments and distribution factor for the substitute frame. So this is the substitute frames, and you will make the table in the same way. Now my this moment is minus 31.25, it is 0, it is 20.83, this is 0. Same way, the same procedure we will follow, and finally you will get these moments. These moments you will get the same procedure, and this will be like this. So minus 16.9 means anti-clockwise, plus 16.9 means clockwise, plus 16 this is clockwise, and minus 9.1 is anti-clockwise, this is clockwise, this one is anti-clockwise. For this also, so you have to stand here, then here inside reference face is the inside face for this minus, and this is plus. So you will draw the diagram in the direction of the arrow. So this will be the same way, 16.91, 16.91, and this is 9.11 and 9.11. This is hooking, and there is a point load. So this will be like this, and there is a UDL. We will superimpose this one. So same procedure you will follow here. So you will get this one is 22.14, and this will be 45.59. Same thing you will get. So this is the end of the lecture. I hope you enjoyed my important lectures. Thank you very much and good night.